Hi, my name is Dr. Tishan. In this video, we're going to take limits of piecewise functions. A piecewise function, as the name implies, is a function given to you in pieces. When you're taking the limit of a piecewise function, you're going to have to take the limit of each piece separately. So let's see in an example here how this works. So we want to take the limit as x approaches 3 of our function. In our piecewise function here, we're given x cubed minus 7 for all the x values less than or equal to 3, and then 2x squared for the x values greater than 3. This is a piecewise function because it's given to in pieces. When you find the limit of a piecewise function, your one limit problem just became 3 parts. It's like 3 problems in one because you have to evaluate each piece separately. We have to take the limit as x approaches 3 from the right, okay? That superscript of a plus sign means from the right of our function, okay? We'll have to take the limits as x approaches 3 from the left of our function. All right, so from the left of our function, and then we need to take the limit of the function as x approaches 3. So the limit as x approaches 3 of our function. So really, when you're taking the final limit of the function, you're really just looking at the left and the right and seeing if they're going the same place or if they're not, okay? Just real quick, I just note, I am filming this in my backyard, so pardon the background noises. We have airplanes flying overhead and there's some dogs barking and some things going on. So just pardon the background noise. All right, so anyways, let's go back to this. So we want to take the limit as x approaches 3 from the right. Now, which piece is from the right, okay? You have to look, I mean, you got 2 pieces here. One of these pieces is from the right. One of these pieces is from the left, okay? How do we know which piece is which side? Well, x equals, 3 is our number, right? 3 is our number. So if I draw a number line and I put the number 3, there's our number line with a 3 on it, okay? Now, this is the right side of 3, okay? And this is the left side of 3, okay? So this is where 3 is. Here's the right, here's the left, okay? On the right side of 3, that's where the x values are bigger than 3. On the left side of 3, there's where the x values are less than 3, okay? I mean, yeah, it's just as simple as that. So on the right side, the x values are bigger than 3. Left side, x values are less than 3. We want to evaluate the limit as x approaches 3 from the right. These superscripts, plus sign after means from the right, from the left if it's a minus sign. Okay, so from the right, which piece is from the right? Well, the right side is where the x values are bigger than 3. They're bigger than 3 down here. It's the bottom piece, isn't it? Okay, so 2x squared. All right, and that is your piece that's from the right. Which piece then would be from the left, okay? Well, from the left side of 3, those are your x values less than 3. Less than 3, that would be your top piece, x cubed minus 7, okay? So you plug your pieces in, and then we compute the limit. You compute the limit of each side, and we just use the direct substitution principle. You're just going to take the 3 and substitute it in, okay? So you end up here with 2 times 3 squared, okay? Evaluate order of operations first. So 3 squared is 9, and 9 times 2 is 18. So here's your limit. Here's your limit from the right side, okay? What about the limit from the left side? Take the 3 and plug it in. We're going to have 3 cubed minus 7, okay? 3 cubed is 27. 27 minus 7 is 20, all right? So what do we have here? Well, this function here, the limit from the right is 18. The limit from the left is 20. So how do we conclude the limit of the function as the x's approach the 3? Well, if the right and the left are not the same thing, we have to say that the limit does not exist. It does not exist. Okay, so this limit does not exist. Okay, so I mean, that just means that when you're taking the limit, the left and the right, they're not meeting at the same place, okay? So if I can give you a quick little graph, let me see if I can put a quick little tiny piece of a graph up here, okay? So here's an x-axis, here's a y-axis. What does our piecewise function look like, okay? Well, x equals 3 is where it's going to split up, okay? At x equals 3 is where it splits up. Looks like to the left side of 3, we have the cubic function that shifted down 7 units, isn't it? So our cubic function that shifted down 7 units, so it's looking something like this, okay? all right, coming in at 18, okay? And then that's the left side. Actually, it's coming in at 20. And then the right side, we have the quadratic, okay? So quadratic starts at the origin, but let's see, we're picking it up at 3. So at 3, it looks like it's doing something like this, okay? So this is about a rough sketch of what the graph looks like. And as you can see, the cubic is coming in from the left, the quadratic's coming in from the right, and the cubic and quadratic are not meeting, okay? So they're not coming together, not meeting, okay? Now, what about the fact of where it's equal to 3, okay? Well, remember with limits, we're not concerned with what's happening at that point, right? With limits, it's all about what's happening as you approach from the left, approach from the right, okay? You have a piecewise function, and you're working at this point right here. Well, not concerned what's happening at that point, right? We want to know what's happening as you approach from the left, you approach from the right, okay? Let's take a look at another example. All right, another example, find the limit as x approaches -1 of this piecewise function, which is given at 4 minus x squared for x values greater than -1, 4 plus cosine of pi times x for the x values less than -1. We want to find the limit of a piecewise function. Your one limit problem just became 3 parts. In order to evaluate the limit of a piecewise function, you have to check out the limit from the left, limit from the right, and see if it's going the same direction, okay? So let's write this one up. So we want to take the limit, okay? X approaches -1 from the right. We want to take the limit x approaches -1 from the left, okay? All right, which piece is the right? And then we're going to merge these together, and we're going to get the limit of the function, okay, as the x's approach -1 of the function, all right? But we don't know what the limit of the function is until we see if the left and the right are going the same direction. All right, which piece is the right? Okay, which piece is the right piece, the right side of -1, or the value is greater than -1? I'm not going to write the number line down again, but so what's the right side? Well, the top piece is the right side here, so it's going to be your 4 minus x squared quadratic. That's your right side, okay? So your left side would be the x values that are less than -1, and it would be 4 plus cosine of your pi times x, all right? And so we're going to evaluate each of these two limits using the direct substitution principle. Just take this number -1 and plug it in. So the top piece, 4 minus a -1 squared, okay, which is 4 minus 1, -1 squared is +1. 4 minus that +1 gives you 3 from the left, okay, or 3 from the right. So your limit from the right is 3. Let's check out the limit from the left now. Take -1 and plug it in. So this gives us 4 plus the cosine of, plug in -1 times pi. All right, so -1 times pi is a negative pi, isn't it? Okay. What is the cosine at negative pi? Unit circle. Well, because you have a negative angle measure, then on your unit circle you need to go clockwise, right, to get over to pi. And so clockwise, and so that value is -1, isn't it? Okay. So this is going to give us a 4 plus a -1, so we have 3. So the limit from the left is also 3, okay? So the limit from the right is 3, the limit from the left is 3, okay? So what is the limit of our function? Well, the limit of this function is going to be 3, because we took the limit from the right, computed it, got 3. We took the limit from the left, computed it, we've gotten 3. What does this mean, okay? This means that as the x's approach -1 from the left and the right, the y's appear to be going to 3, okay? All right, remember, and then the equal to, not concerned about what's happening at that point, because limits, when you study limits, it's all about what's happening as you approach from the right, as you approach from the left. And if the left and the right are going the same place, then that is what the limit is. It's telling you where the y's are going from both directions. All right, when the left and the right are different, limit does not exist. That's just telling us that the left and the right are not going to the same place, okay? We could probably, let's take a quick look at this graph, okay? All right, let's see what this graph might look like. So I'm going to sketch the graph for number 2. Let me just try to sketch it way up here, okay? So here's the y and here's the x, all right? So what do we have for this graph? Let's see, we have the 4 minus x squared, and so that's a quadratic that opens down, right? Shifted up 4 units, not included, and we're concerned at the -1 points here, so 4 minus x squared. So it looks like we're dealing with, there's the piece of the quadratic, right? We don't want the whole quadratic equation. This is a parabola that opens down, shifted up 4 units, but remember, it's a piecewise function. So we don't want the whole parabola, we just want a piece of the parabola, the piece that spans from -1 to infinity, okay? Now, what about this trig? So you have the cosine curve, okay? And the amplitude of the cosine is 1. The period is going to be 2 pi over pi, so the period is 2, shifted up 4 units, okay? So this cosine curve here, we're up here with this cosine curve, okay? And this cosine curve happens to be connecting right there. So see, they will, if you look at this in graphing utility around a computer, the cosine curve coming in from the left, okay, and your quadratic function coming in from the right, they're going to connect, okay? That's why we have a limit for this one, okay? But over here, your cubic function, your parabola, they didn't connect, okay? They didn't connect. So because they didn't connect, we don't have a limit here. They're not going to the same place from the left and the right, okay? So that's what all this stuff means, okay? So I hope this helps with your study of limits and piecewise functions. And again, I'm in my backyard, so pardon any background noise, and that's it. If these videos do help you, I would love for you to subscribe to my channel. So there's a button down below the video where you can just hit subscribe. So if they do help, I'd appreciate that. Okay? All right, thank you so much, and bye-bye.